So now we're going to get into what these firewalls are all about, which is security zones and how that works, how that's a little different than what you guys have probably played with, whether it was OpenSense or pfSense, where they're starting to get into zones in those as well. But your old Linksys routers, that kind of stuff, you guys just did basic NAT. Now we're going to get into zones, the different types of interfaces that you can have, and there's a lot on a Palo Alto, and then what virtual routers are on the layer 3 side. So jumping into zones, we use zones as a way of network segmentation in order to secure access of the data. So to understand what's in there, we kind of break people up into groups of who must access what and use the principle of least privilege, meaning we kind of want to group them together with the least amount that's in there. And then consider any kind of regulatory requirements we may have to keep for certain people to go away. So for example, those that are contacting the customer or have access to customer data, accounting and sales needs access to that, but sales does not need access to the credit card data, right? And our external web applications, we both need customers and HR to access that, but obviously customers don't need access to employee information. So we try to break up our segment so that those people would never have access to this kind of stuff coming in. And we do that through the use of security zones. So typically we would have something like an internet zone, public zone, extranet, something like that is usually what they're going to call it. And then we have somebody like Bob over there in a particular like business to business type zone over there. We could have the accounting zone, a PCI zone, an extranet zone out here on the side. And those are all just different places on the network we can stick them. They can be on the same subnet, they could be in different subnets. There's different ways to break that all out. But the goal is that when we start assigning policies, we focus on the zone. So zone HR accounting can get access to the internet. And when we put in that policy, we only allow certain things on the internet. Or maybe if it is the admin group, they have full access to the internet. We don't restrict what they're actually going out to. But we also may not want, admins to be able to jump into HR or HR to be able to jump into admins. We can set up different rules based off those zones. So in this case, they're showing that Bob in the accounting zone has access to the PCI zone. However, our internet zone and our extranet zone do not have access to that. And we would set up rules accordingly. So this is what our policy rules would look like, where Bob in this B2B zone up here at the top has access to the PCI zone, which is where we have like our MySQL database in this case. And accounting would have access to that as well. But just those two rules would be in place for them to have access to PCI side. Anything else is going to get to this particular rule, and this will be more apparent when we talk about rules. You have inner zone, in which case, if it's always within the same zone, aka an HR person is trying to communicate with an HR person, we always allow that by default, unless we set up a rule otherwise. But if they try to go to any other zone or interzone versus intra, right? Intra, inter, it's going to be confusing for a while till you get it straight in your head. Intrazone is within, interzone is between two. And so in this case, if it's between two zones, by default, we drop it and we won't allow any traffic going between them. In a zero trust architecture, we never trust and always verify, meaning if we don't have a rule for it, that traffic goes nowhere, right? So we always inspect inbound traffic and outbound traffic, and we can also inspect our internal traffic. So because Sally and Jim are both in the HR department, we can actually restrict what Jim and Sally can communicate with one another as well. By default, we don't, but we can also put policies in place to inspect that as well. Does anybody know why we may want to look at traffic between Jim and Bob, even though there are Jim and Sally or whatever names I used between HR? You got it. So if there's any kind of ransom or spyware, malware that's infected on Jim or Sally's PC and trying to communicate with other ones within that zone, we don't want to always allow that traffic out. We may want to actually inspect that traffic because that's going to be the first zone that it always has access to, right? We have no restrictions there. So it's going to try to infiltrate anything within that zone and then try to go bounce between other zones for whatever policies we have available to it. When we talk about firewalls, anything that goes from the firewall to the internet is usually described as north-south traffic. Anything that's between zones behind the firewall is east to west traffic. All right. Does everybody see what that means? Has anybody heard this in a thing and was like, why are they saying north, south, east, west? This is why. All right. So network interfaces, when we're talking about physical firewalls, you will have Ethernet interfaces over here. So for example, like on this big blade switch, anything in this first 1U chassis at the top is going to be 1/1. Anything in the second blade is going to be 2/1, 3/1, moving its way down. If it's just a single slot firewall, aka like my PAN 20 or my PAN 820, that kind of thing, you're going to have 1/1, 1/2 going all the way through there. If you are using logical interfaces, you would have something like 1/1 and 1.2 on the same interface. Does anybody know what those logical interfaces might be used for? You did something like this in Cisco.
VLAN.
VLANs, right? So you guys set up VLANs and you set up those logical interfaces in order to act as the router on that particular VLAN. Same concept here with logical interfaces. That zone can include either multiple physical interfaces or logical interfaces. Doesn't matter which one. But each interface is assigned to one zone. So you can't be a part of HR and part of admins. You're one or the other when you're in this interface. Okay. Interface types, you're going to have a couple different ones. So you're going to have tap interfaces, and we'll talk about what tap interfaces are used for. We have tunnels, in which interfaces would be assigned. It says none there because when they are assigned to it. On a a layer 2 zone, you would have layer 2 interfaces. What's the difference between layer 2 and layer 3? Anybody remember that from John?
Layer 2 has the MAC address. Layer 3 has the IP address, right?
Right. So what's the main difference between those two? Routing, right?
Routing,
so layer
yes.
2 is always going to stay on that same subnet because you can use what protocol in order to figure out something else on that network. Does anybody remember that protocol?
ARP. ARP.
Yep. So you would use ARP to do what? Does anybody remember what ARP does?
To identify the device.
And by device, which address?
Populate that MAC address in the ARP table.
Yes. So what you're doing if you remember in Wireshark when you're in John's class, it would reach out and say, who is 192.168.1.2, right? And it's going to be responded because it goes out across that layer 2 network. The switch will either respond and say, that is this MAC address on my port. I can handle traffic. Or if that network or that device is on that network, it can come back and say, hey, I am 192.168.1.2. Here's my MAC address. Throw it in your ARP table, right? On a layer 3 side, that's where we're going to be routing between more than one subnet. All right. So layer 2 means that we can turn these ports into essentially a what? What kind of devices do we use at layer 2? Switches. Yep.
Switch.
So we could end up turning a bunch of these ports into just a switch on that particular area. That's what a layer 2 interface would give us. By default, we can set them to all sorts of different types, right? So if you remember on a switch, you typically have like 24 ports here, and then maybe you have 2 uplink ports on the side. Or on a Cisco router, you may have 2 interfaces over here, and then a bunch of switch ports on one side, right? This allows you to assign whether that's going to be layer 2 or layer 3. Once we assign it layer 3, that's routing, which means it will have a what? It will have an IP address, right? So that way, when it gets routed to other subnets, we know that that interface is our .1 or .254 or whatever we assign it for that to be. Great. So on your layer 3 side, you could typically have that as your layer 3 interfaces. In other words, they'll get their IP addresses. You could also set them up as your VLAN interfaces at that point. Your VLAN interfaces is basically those sub interfaces we talked about, or logical interfaces. You can set up loopback interfaces and or the tunnel interface itself when we connect out to a physical tunnel or to a virtualized tunnel. The other one that's a little tricky is virtual wire, and we'll talk a little bit more about that and when we would use that. So in those zone types over here on the left, when we create a new zone, you go to Network, Zones, Add, and then you can pick a name and then you pick one of these types that are going down. And so usually most of you guys would use layer 3 interfaces, right? That's typically what you would do on a firewall. But these firewalls have the ability to do a lot of different things. So in our case, we would pick like virtual wire or layer 2, layer 3, and go on for what type. And so these are our different types. So when you deploy a firewall, you guys are mostly used to something here like layer 3, in which case you have a WAN port on your firewall. It connects out to what? Anybody remember what WAN port is?
Ethernet.
Wide area,
Gateway.
which is
Gateway.
your gateway.
That's going to connect to your gateway router.
Internet. That's the word I'm looking for, right? So your WAN is coming out. Your WAN ports are your internet ports. That's where you're connecting from your ISP into there, unless you guys are doing a multi-campus network kind of thing going outside, right? Typically, that's your internet port. When you go from that WAN port, you go to a LAN port, and LAN being your local area network. That's where you guys are going to control all your traffic inside here, which typically uplink to switches. And so in your case, you're going to have a layer 3 interface here, which gets DHCP or maybe PPPoE, depending on what your ISP gives you, or maybe a static that you have to statically assign. You would set that on this interface, and on the inside would be your 192.168.1.1 or .254 or whatever subnet you have. That goes down to switches, and then from there, all your PCs would connect into those switches. All right. When you're doing a layer 3 like this one over here, it allows you to see all traffic that goes through there, right? But we're also intercepting that traffic inside of there. So if something comes from here, in order for it to get out to the internet, it has to go through here doing what usually? If we're taking inside traffic going to outside traffic.
Or you would inspect it with your security services.
Deepring.
Yeah, you would have your security services, but what do you guys typically do in order to take a bunch of local IPs to get to a public IP?
Network address translation.
Network.
Yep,
NAT.
Yep. So your NAT or your network address translation is going to take all of your inside IPs, translate it to one single public on the outside. So this device would have to perform NAT. It would have to perform all the routing going outside. It has to pretty much do everything. But that's usually the way most firewalls are deployed. In a virtual wire interface, what that allows us to do is have other firewalls in place, and we can just pin ourselves in between here so that we can intercept traffic as it flows through us. So at that point, we are not handling NAT. We're not handling anything. We are just sticking ourselves between. It's like literally unplugging a cable, plugging it into a bridge, if you remember bridges, and then plugging back into the other switch. We have officially inserted ourselves at this layer inside of here, right? So that's where you would use virtual wire. You can do some NAT in there. Typically, that isn't where you would do it, but that would allow you to take advantage of features like app ID, content ID, user ID, and even SSL encryption. Meaning we can do all the content filtering, layer 7 deep packet inspection stuff by sticking ourselves inside that wire. But these PCs don't know that we necessarily exist. That makes sense? They still think they're hitting this outside firewall and going out to the internet from there, unless we're doing that at that point. And then TAP, which is typically what you would use when you're trying to test out a Palo Alto firewall or test out a new firewall in your network. And what you do there, does anybody remember what we called those type of ports on a switch that allows us to see all traffic going across that switch? You guys would have learned that.
It's like promiscuous mode.
Kind of like promiscuous mode. There's a particular port that Cisco calls it when you want to get all traffic shoved to it.
An uplink port.
What was it?
Uplink.
Nope. Very close to a mirror port, right? They called it a span port, is what they called it in the Cisco world. So you had span and mirror. The idea is that you're taking all traffic on that switch and shoving it out one port so that we could listen to it with Wireshark, we could listen to whatever. Because if we just plug into a switch and try to turn on Wireshark, are we ever going to see traffic between two devices?
No.
You wouldn't necessarily know, right? You would see broadcast traffic, in which case we're sending it out for everybody to respond, but you wouldn't see communication between two devices because
Because the ARP table would direct it directly from one port to the
MAC
other,
address.
and it would
You got
never
it. That's exactly
broadcast
right.
anything else.
It would, this ARP table or CAM table inside the switch is going to say, nope, I hold the MAC address is directly connected to me. I'm connected here. That traffic just goes there. We don't ever see it off another port. A spam port allows us to send that traffic out to a device so that we could run Wireshark on it or we could sniff it out. Back in the old days, that's where we had bridges, right? And so a bridge, when I plugged into a port on it and I plugged another PC into another port, it sent that traffic out all ports, right? Which is great for doing things like Wireshark, horrible for security, right? Because now I can see all traffic going across the entire network. But the old techies used to keep a bridge in their pocket or their bag, plug it in between because it was a way for us to tap in. And you guys may even see those devices. They're called like network taps. It's the same concept. I'm taking traffic in on this wire, and it comes out to another port. I plug a laptop into there and I'm able to essentially just sniff traffic. I can't register an IP. I can't see any of that, but I can sniff the network traffic as it goes across that device. That is essentially what a tap is doing for us on this side. So as a tap, that allows us to see all applications, any kind of things that are traffic in our network. And we typically use that as an evaluation or an audit of existing networks so that we can set up rules to say we're going to allow, oh, this network uses Microsoft SharePoint. Okay, we need to have a rule for SharePoint, or we're going to allow that app. Remember, in a Palo Alto, we're trying to get away from the old school way of doing stuff, which was by IP address and port number. You know, allow port 80, allow 3389, allow this kind of stuff to this specific application. And that way, if somebody changes the port number, we don't care. We recognize that traffic as Microsoft SharePoint traffic or Google app traffic. That way we can block that traffic if we don't want it on our network. We can't block port 80, right? Or 443, it just wouldn't work for us. So tap ports are great for us to get an idea of what's going on in the network. So we can figure it out. We can then start to make initial rules. I can walk in with a PAN 220, set myself up as a tap interface on your network and start actually collecting all traffic back to that so I can get an idea of what's actually flowing on the network. It's basically a Wireshark on steroids doing all that kind of stuff, right? Because Wireshark's great. We can do a PCAP file and figure it out. But can you guys sit there and read Wireshark and know if that's SharePoint traffic or Google traffic? Or if you can, you're in the wrong class. You guys need to be somewhere else because you're beyond me. If you can, you're really cool and you're really good at networking and you should be able to do the Wireshark stuff like that. And if you're interested in being that level of Wireshark, I've got some hookups that are the lady that writes the academy for that Wireshark program. She literally uses Wireshark on satellite traffic going to NASA to do space telescope stuff. It's nuts. She will use Wireshark for anything. It's kind of scary. Really cool because you can actually do an audit of existing networks and really figure out what's going in traffic-wise. So lots of different uses for a Palo Alto. Another good way of doing this side of it is even if you don't have a physical device, is firing up a virtual machine. So you could fire up the VM50 like what you guys are using in the classroom, send it a bunch of this traffic so we can see what's going on the network without ever touching the network. All right. Again, most of the time in most networks, you're going to be doing layer 3 where this guy's just handling everything in the side, right? Every now and then you'll want to do this virtual wire if, say, maybe they have a Cisco ASA type firewall deployment and we're just purely wanting the power of the Palo Alto to do the app and the ID and all that kind of stuff because the Cisco ASA doesn't have that capability. Or for whatever reason, it's cheaper for us to do it on Palos. I don't have any idea how that would ever happen, because I went to go price Palo Alto services the other day and it was, once again, not cheap. Several $1,000s for a license. Okay, so again, tap interface. We're going to set up our switch with a span or mirror port, just Cisco terminology versus other vendor terminology. We're going to set that up. And again, that's taking all traffic that goes across that switch, putting it in that port so that we can stick our Palo Alto off that port to listen to it. And at that point, we can go all the way through. We must assign it as a tap interface. We cannot control traffic or shape traffic or do anything like that. We're essentially just enabling passive mirroring of that switch so that we can see what's going on in the traffic log. We're Wiresharking with our Palo Alto. That's all we're doing at that point. So to configure that, we go into our interfaces, we set up a tap interface, we tell it what network we're going to, the physical network port 1/3. We set a comment for what we're wanting to do, and then we can set up a monitor only security zone so that we could do any kind of traffic in between. Virtual wire allows us to bind two network firewall interfaces together through a virtual wire. In other words, I'm going to plug this into 1.1, I'm going to plug this into 1.2, and I just so happen to be in between. Otherwise, we're going to allow all the traffic to flow in and out of us. All right. It's typically used when no switching or routing is ever needed, right? We're not necessarily doing NAT or that kind of stuff, even though it can do it. We typically just want to be in between and listening and filtering the packets as they come through, right? No configuration changes are needed for any of these other devices, which is another reason you may want to walk into a company. They're not going to allow you to touch their stuff, but you want to demo the power of your Palo Alto. You can set up a virtual wire between that and say, this is going out your firewall. We could have blocked it here. And you could see that when it's off, it goes all the way through and goes out to the net. When you turn it on, now we're blocking that kind of traffic. And a good example of that would be like when you set up the policies for social security numbers or stuff like that. If you type in your social security number in a document, Palo Alto can actually register that kind of traffic flowing through it and block the traffic. It can detect any of that kind of stuff in between there. So it's no longer caring about whether you're using Google or SharePoint or any of the other stuff. It just knows that that is a credit card number or that's a social security. We're not allowing that stuff on our network. Don't let it ever go outbound, and we can block it. Setting it up the same way, you go into your virtual wires, you add two interfaces. So in this case, 1/1 or 1.4, 1.5. And if we want to forward any of the multicast traffic going through there, we can do that. And then whether this link state is forward, does anybody know why that might be handy? So remember, we're creating a virtual wire from this interface to this interface on like a switch, right? When we're going upstream here, normally this switch is directly connected to that firewall, just like it is here. We're plugging our cable into here. If we unplug the cable when we no longer need it, what's going to happen? We do it here, the switch recognizes this interface goes down, right? But if we unplug this one, what happens here? Layer one still thinks it's up, right? It can't pass traffic, but layer one, the link going between there at the layer one connection, still thinks I have a 100 meg link or I have a 1,000 meg link going on here. So link pass through says if this connection was to break, tell this connection it's also dead. That way the switch can go, uh-oh, I don't have traffic. It starts sending it out this way and going back up, right? So when you guys have these high availability style networks, it's not really a mesh, but a high availability side where if this firewall goes down, traffic can go over and back up. But if you don't do that link pass through, it thinks the interface is up and then traffic just starts falling off because it has no place to go. Okay, setting up virtual wires. We did that at the top. Down below, you're going to set up whatever virtual wire device that we set up in this screen. And then down here, you're going to set it up to some kind of security zone. In this case, they attached it to danger so that they could see it getting filtered at that point. And then the last one is going to be your layer 3. All right, this is going to create a virtual router configuration, meaning that we have IP addresses. It's going to require that the network configuration accommodate whatever IP addresses that we're inspecting or passing traffic through. So typically you would not do this unless you're going to make configuration changes on your network. Does that make sense?
Wait, Jason,
Yeah.
did you mean to point the camera to the whiteboard? Because I'm not able to see on the whiteboard.
It's supposed to be tracking me. Sorry. Why is it not tracking me? Am I? You should see the screen share though, right?
Yeah, I do see the screen share, but it's just right now, all I'm seeing is the bunch of computers on your desk. That's all. It's not like tracking you.
Oh, for the camera.
Camera. Right. Yeah, for the camera. Nope.
Well, now it's not tracking me anymore. Okay. I'm not that pretty, bud, but Maybe.
Nope.
Nope. Huh. I'll tell you what. I'll just pan it that way.
Other way. Yeah.
Tell me when you see it in your frame.
Yeah, it's coming up. Yep. A little down. If we scroll down a little bit. Yeah. No. Scroll down. No. You missed that. Yep.
The camera is doing what it wants to do right now. That is not down. That is not up. Huh. That's pretty bad. All right. We're going to turn that off. We'll go old school for today. There you go. How about that? It's not great, but it's something. That better? Did I lose him?
Yeah, that's better as long as we can see what you were indicating on the.
Yeah, so that's what I was going to ask. If you were just looking for what I'm pointing at, I'll do this, and I'll point at it. That'll be easier when I go through there.
Yeah.
Sorry, I just wasn't pushing the button I thought I was. Okay, there we go. We get a nice little marker, and you should be able to see that too.
That's better.
So again, layer 3, this is going to be the IP address. We will have to set an IP address here. This would be your either inside zone or outside zone, whichever one you decide zone A is, and then setting an IP address on this side. You'll have this virtual router inside. We'll talk a little bit about virtual routers, but that allows it to do the routing traffic on top of the firewall stuff that we're doing as well. When you set up the sessions on there, layer 3 interfaces can either do IPv4 or IPv6. To support that IPv6, we have to enable IPv6 on the firewall. So we go into our session settings, and then we can enable IPv6 firewalling there as well. To set up your IP3 or layer 3 interface with an IP, you come in, add your interface like you've seen on all the other ones. Only this time we are now going to have to set a virtual router down here. Typically, it'll be called default. We can have multiple virtual routers, and we'll talk about that here in a minute. And then from your IP address, you'll set the security zone. Then you'll click on this IPv4 up here at the top. And inside there, you can go ahead and set your IP address down here at the bottom. And so if this is your internet interface, because that's what we're connecting out here, then we can choose whether we want static, PPPoE, or DHCP. And from there, in this case, we set up a static. And so we have that physical static set up on this side. You set it up in this notation so that you're not setting up a subnet. You're actually setting it up with /254, or I'm sorry, /24 if you're doing that kind of CIDR. That makes sense? So everything in a Palo Alto typically has a CIDR notation. Even if I'm giving it just the IP address of 113.20 somewhere else in the interface, a lot of times it's a /32, which means it's its own self, right? So, okay. Anybody have any questions on that side? Setting up IPs, pretty straightforward. Let's see here. I'm going the wrong direction. There we go. Okay. Beyond that, you have the option to click on this advanced tab. And then from there, we can set up other information. For example, this management profile. And that management profile, we can go set up, and that allows us to connect to this interface via HTTPS or SSH or whatever, right? So remember, we have that out-of-band access, but we may also want this interface to allow us to log into the UI from it, right? Typically, you wouldn't want to do that on this management profile, but you might want to allow ping, right? Because if you're a PC on the inside network, you want to make sure you can at least reach your gateway. You have to allow ping. If you don't do it, it just doesn't respond. Doesn't mean it's not there, it just doesn't respond. So a lot of times for troubleshooting purposes, you will at minimum go in and allow ping. And in this case, they just created a management profile that is preset up to allow just ping. ARP entries allows us to set up preloaded ARP cache. This is important sometimes in data centers, depending on when you're uplinking to your core data center switches and such. You may need to manually set ARP entries or ARP static cache inside of there in order for things to translate. So I won't go into detail how that works. I'm just going to say after troubleshooting for 24 hours in a data center where it was cold in one aisle, hot in another, and no food, ARP cache entries. All right, memorize it, because when you're trying to figure out why things aren't working like it should, it's probably ARP. And that's on the upstream. Let's see. ND, that's only going to be reference to IPv6. Does anybody remember what ND means for IPv6? IPv4 was ARP. IPv6 is, and I barely remember this because I learned IPv6 and then the world didn't use IPv6. So neighbor discovery, right? So you guys are going to use neighbor discovery. That's what replaced ARP entries when you're on IPv6. NDP proxy, and then LLDP. Does anybody remember what LLDP is? I'll give you a hint. The P means protocol. Super helpful.
Lightweight something.
Nope, you're closer. close.
Lightweight directory protocol.
Link
LDAP?
is the first one. Yep. Link layer discovery protocol. Yep. Does anybody remember what that's used for? You got it. And Cisco, that allowed you to go through and be able to see who your neighbors were, what layer or what ports I'm directly connected to. So if you're using that protocol, it would allow you to say, hey, you're connected to Cisco switch 1/45, whatever on the other side. They all have to talk LLDP on that side as well. Yep. And then DDNS, does anybody know what that means? Some of you home users might know that quite well. Well, you know the last three, right?
Dynamic DNS.
DNS. So you have your domain name service. What do we use domain names for? Yeah, it's much easier for us to
Translate
know text
IP
than
to.
to memorize IPs, right? So what DDNS is dynamic. And so if you guys remember, in order to set up a DNS entry, we have to have a static IP address to a static entry, right? Dynamic allows us that if we have a DHCP on our side that you're getting from the internet and that changes every now and then, you would have to go and update your DNS entry all the time. This is a service that does that for you, right? Very common, like for you guys at your home networks, where most internet service providers, you don't have a static IP. So you want to make sure that it always translates jasonzeller.me to some IP address out on the net or whatever your domain name is. All right, let's see here. This is back to that management profile we talked about. So this was the allow ping. This is a profile you can set up, in which case you can determine whether or not you want access to those administrative services. Again, typically you may or may not turn this on only for certain interfaces, like maybe your management network, but you already have that out of band connection, so you probably don't need it. But you may want to allow things like ping or SNMP or even a response page in order for you to get back some information to make sure that that service is up and running. You can also lock that down to permitted IP addresses, and I encourage you to do that. So if you do enable this on the inside, maybe you only allow your admin network or your admin user's laptop access to this interface at that point. If you don't set something, anybody on that network can have access to it. Okay. Sub interfaces, again, this correlates back to your VLANs like you guys mentioned before. So this first port could be connected to 1/1, and then we may have multiple interfaces coming off this guy here. Does anybody know what that's called on VLANs, where we have multiple VLANs associated with one port? An elephant has one. Hey, see, the jokes are real, but you at least get the joke. We're good. Trunking. So on your VLAN trunks, that allows you to have multiple VLANs pass over that particular port. So if you were on Cisco World, we would set that up as a VLAN trunk port. Otherwise, if it's not a trunk port, it's a, anybody remember on the Cisco World? Access port. Yep. So, and an access port basically says any traffic coming into here, I'm going to start tagging it with this VLAN traffic. The reason for doing an access port is so that I don't have to go set the VLAN on my end device, right? Otherwise, I got to go configure my laptop to be on VLAN 10. If I do a access port like this guy here, then any traffic coming into this port is now going to get associated with VLAN 10 at that point. All right. The beauties of doing something like a trunk port is you have a finite number of interfaces. Sometimes you don't have, the giant 48 monstrosity firewall, the Palo Alto coming through there. You only get 4 ports. And so you would end up trunking one of those so that you could break it out to multiple VLANs. You could bring that as a trunk port down to a switch, and then you could have a 48 port switch in order to give you all those extra interfaces on the inside. Now, one caveat to doing that, and they're not going to really talk about it here, but I will mention it because I ran it in the real world, is what's the beauty of having this whole port dedicated to this VLAN, but we're going to run into something with having 3 VLANs over here. Anybody know what that might be? So if I'm over here in this VR1 zone, if I want to go over here to the HR zone, I have to go up here and back down here, right? And if I'm over here on the ING zone and I want to get to the DMZ, I got to come up to here, go across this, and then go back out that direction, right? But what happens if I have 3 of these VLANs coming to one port?
You limit your bandwidth more.
You got it. Yep, exactly. So here I have a full bandwidth to the firewall that if I'm transmitting something from here to this network, and these are gig ports, I could theoretically, as long as this firewall could handle it, do full gig routing over to the other side, right? But if I have 3 people down here connected to this port, and they all turn on file shares that are going out to this port, then I'm going to get capped over here. I will get gig to gig throughput from here to here, but once this comes in, if I got 3 coming out, I'm never going to get that full traffic out of this port. So you would typically want to do that with your fastest port, if at all possible. So if you have 1 gig ports and then a bunch, a 10 gig uplink style port, you would want your 10 gig port to be your VLANs so that it goes down to a switch, then gets broken out to a bunch of 1 gigs. Now I can still get 1 gig throughput between these 2 here. All right. So typically on like a firewall like this, you would want to use your fastest port for your VLAN traffic, if at all possible. And then you would attach that to a switch that has the fastest port so that everything routing up through there is there. But this has been a bottleneck if you're not careful, especially if you're doing this with storage networks. You probably want to do something like this. Of course, you shouldn't be necessarily routing a storage network, but you may want to do that in there as well. Okay. I know it seems irrelevant, but I'm going to save you hours in a data center trying to figure out why this stuff doesn't work. Okay, adding sub interfaces is fairly easy. You go into your port over here, pick which one you're going to do. In this case, we say 1, 2, add sub interface. Now we can set it with the tag number of the VLAN tag that we're going to be using, which, sorry, I guess I'm pointing there. We could use that VLAN tag here. You set this sub interface ID. Typically, you want these 2 to match, right? It just makes it easier for you to remember. So that we remember that 1/2.1 is actually VLAN 1, right? And VLAN 2 and VLAN 3, et cetera. Doesn't mean that it has to be set that way, by the way. But you would be a very masochist administrator if you chose to do it not that way, because you're just going to cause yourself some trouble. All right. Last piece of it is virtual routers. So virtual routers allow us to have 1 or more static routes, just like you guys set up in a Cisco router, right? You guys remember that? You go in there, you set your static routes. If you're not using static routes, you probably use what other protocols?
Dynamic
protocols,
DNS.
right?
Yeah.
So something like BGP, OSPF, RIP. Usually you guys are using RIP or something on the inside, right? OSPF is typically used on that inside as well. BGP is used where? Does anybody remember what BGP stands for?
Border Gateway Protocol.
Nice. There's a guy.
The ISPs use it.
Oh, it's RJ. Yep. See, RJ knows what he's going after, right? So yes, BGP is used by ISPs. That's what allows them to communicate with other ISPs and also how they're going to route their traffic. So a great example. Sorry, RJ, I'm going to put you on the spot now. So RJ works at Nextech. If he's working on that side and had to work with any of the technicians, they're not able to access a website, but they go over here to Verizon and it can work just fine. It's probably a route that allows them to connect to that Verizon network out. And maybe that BGP's routes down or something else in between. Okay. There's a couple other protocols that are used on that outside fringe, but BGP by far is the most common. So this allows us to have multiple Cisco routers all in one box. All right. And the beauty for us, if you guys remember, is because I can put a firewall in a location, maybe it's in the mall, right? I can do multiple tenants, AKA multiple stores running through my firewall, but I can keep everybody separate so that your traffic never touches their traffic and their traffic never touches your traffic going through. And it's not done by policies. It's just like having multiple physical routers connected. This saves you rack space and everything else. You can create virtual routers to do all that for you. All right. So you could do multicast routing, the PIM and the SIM. This is typically done phone networks, or maybe if you're doing IPTV type stuff is where you would get that multicast side. All right, so virtual router interfaces that you see up here. Again, your interfaces must be associated with a virtual router for layer 3 interfaces. So we can associate them in there. If you want to create a static route, almost always we create a default route, which is our quad zeros. You guys remember that. And quad zeros allow us to say, if we don't, what? Send it out this interface, right? Yep. So if we don't have anything in our route table that is associated with this, in this case, we're going to send it where? Based off this screenshot. Yeah, in this case, we're going to send it out our interface 1.1 to our next hop address, in this case, of 203.0.1131, right? We could change, instead of this drop down here of IP address, we have the option of just saying send it to the next virtual router. We could send it out to a fully qualified domain, or maybe we just discard it. In other words, if we don't want traffic going anywhere unless we specified what it is, kill it. Down here at the bottom, you could set up your administrative distance or metric. You guys remember what those are from your Cisco days? That allows you to what?
You kind of set the cost on it as to which one's going to be the best one to send it to.
Yep, that's a great, yep. So your metric is kind of like a cost, because sometimes they use the word cost in the Cisco curriculum. But yes, that allows you to determine which one has priority over another. Or if you have 10 default routes, in other words, send it out this way. Or maybe I have 2 WAN uplinks, and if this one fails for whatever reason, send it out this other link on the other side. Okay. And that's what it's talking about here on setting up multiple static routes. So for example, we could have this virtual firewall that has a default route coming out. Where would we use something like this? Where we would have multiple default static routes.
If you had a HA, you would have multiple static routes.
HA would be one. And HA, are you referring to high availability on the firewall level?
Well, I was thinking like multiple WAN connections, for example.
Yep, that's exactly right. So HA is typically referring to high availability at the firewall level, but you're right. If we have multiple uplink providers, so that we have failback to multiple internet service providers, right? So in this case, we could have somebody like Nextech over here at the bottom, right? And we could have a Vive connection over here, and we could determine by our routes whether or not we wanted to send it out one ISP or the other. In other words, we may have a better hop count. For example, Nextech and Fort Hayes actually have a backlink between each other, right? So if I'm off campus and I want to route traffic to Fort Hayes, if I go from Vive and link it over, which I believe Vive actually has a connection now, but in the old days, it used to not when it was Eagle. If I could get faster internet speeds, if I could go through the Nextech connection over. So when I had 2 ISPs locally, and I did that because I wanted redundancy, or I could actually double my bandwidth by sending it out depending on which direction I wanted that traffic to flow, right? Same way when you're a business, you typically can't handle having one ISP, especially if you're a big business that are using these kind of firewalls, you typically have some kind of failback, right? And you may not buy a big plan, right? So I may buy like gig internet from this ISP, and I may buy, 10, 50 mega internet over here, which is purely because my main ISP went down. So it's going to throttle me down for everybody, but we're not officially down in there. And I may set it to where just our essential traffic is the only thing that flows at that point in time. Our users may lose internet, but our services outbound to customers like websites, stuff like that, would still be up and responding at that point. Based off ISPs, what's another reason we may want to send that out to other people? So I mentioned if it's down, or maybe I have this gig link and I have a 100 meg link, but what's another reason we might want to? We talked about download speeds typically when we talk about those speeds. Does anybody know, other than RJ, the big difference between Nextech and Vive in this town? What's that? Fiber and coax, right? So what's the advantages of fiber over coax?
Speed, yes.
Speeds, but speeds in which direction? Upload.
Upload,
Right?
yep.
So that's usually the big difference between the two ISPs in town is both of them offer gig services down, right? If you are on a, and this is generically speaking, right? If everything in the world goes the way it's supposed to work, if you have 20 Nextech customers at a location or spread across town, even better, let's say spread across town, and they pay for gig service, they're all going to be able to get their gig service, right? If you're on a coax, that is usually a shared medium, which means if everybody comes home at 5 o'clock and jumps on that, it's going to slowly get slower and slower because that's a shared medium coax going through there. Where Nextech has deployed their fiber in a way that it's called active Ethernet, and that means you will get your connection back to their DSLAM in this case, or their main connection point for all the houses coming back. Those all have gig links back to that node, both upload and download. Now that node can only handle so much, right? But it has like 10 gig uplinks or 40 gig uplinks, which means up to 40 customers can solidly pull all the way through there. A genuine speaking is if upload speeds beyond that were down. On your coax side of the house, your modem is not as strong as the head-in that's sending to you. So the head-in can blast frequency down so that you can get your full gig download speeds, but you can't send gig upload back over coax. Usually that's the case. They've made waves in Mocha and some other things to make that better, but typically you don't have that. So for example, if you go out to Vive's website, and this is not me vying for one ISP or the other, hint, hint, wink, wink, but not true. You will only get 50 meg down on the Vive side. Or I'm sorry, 50 meg upload from the Vive side, where Nextech usually sells it as symmetrical now. They used to not necessarily be full symmetrical. Now they are. You will get your full gig upload or your full gig download going through there, right? That would be important for you as a business doing what? What's that important for?
VPN
Is it important for your
connection.
users that are all on your network trying to access the internet? Or is that important for your customers that are trying to access your web services inside your business? Well, it's back to that upload download thing, right? Which one of those scenarios are we using upload?
Surfing on the internet, streaming.
Nope. That would be download, right? So if I have a Fire TV on my business network and I'm accessing the internet and pulling down that Netflix or Netflix movie, that's download to me as from the ISP side, right? I have gig internet. I can do however many Netflix streams I need to do, 10 meg a piece, do the math, all right? However, if I'm hosting something like video and sending it out to the world, that would be upload, right? So if I have a bunch of web servers and I'm offering a big file sharing, or maybe I'm doing stuff like that as a business and I'm sending that information out, now I need upload speed in order for that to go out. That's the reason when you buy services out in the cloud, you get X amount of download for free, right? And they're like, oh yeah, or sometimes it's unlimited download. You can get all you want. You're like, this is great. What they don't tell you is you're paying $3 a gig for your upload speeds. And the whole reason you're in the cloud is so that you can deliver it out to a bunch of people, which means when those people consume your services, you're paying for every gig that goes out that pipe, right? Yeah, it's not great. Amazon Web Services will explain that to you in very fine print and then send you a bill for several $1,000s. So you got to be careful where you host that kind of stuff. Now, where does that all come back to firewalls? In this case, we may do dual ISPs. We may want a Nextech and a Vive, but if we're hosting our services, we want to route that as much as possible over our one that has the best upload link, right? So we may adjust our dynamic routes or our firewall routes to say, hey, make sure you're always servicing this stuff out this interface and not the other one. The reason for that is a lot of times you'll do that because you're paying for both of these. But if you just leave it over there as a failover or failback, you're paying for something you're never using every month. So you might as well a little bit of load balance between the two connections, but you have to make sure that that traffic routes back to you. And that's where it gets a little hairy, is sometimes you'll send something out this ISP, and then when it comes back, it wants to come back through this ISP. That's a bad deal. So you have to get configuration right so that it goes in and out the right direction. Okay, so static route monitoring, this is exactly what it's doing, is it's going to monitor going out to something beyond your firewall. For in this case, they're going to what? Google, right? They're going to go check quad 8s. In this case, it's going to do pings every 3 seconds for 5 count. If this was to go down, then it determines, hey, your static route for quad 0s is down. I'm now going to reroute all my traffic over to this other side. At the moment this monitor comes back up, aka internet service returns back to that ISP, it will then go ahead and switch the default routes back going out the other side. Okay. When we need to troubleshoot our routes, you can come into your network virtual routers and on your runtime stats over here on the upper right. I can get this over here. I don't know why it switched to the highlight, but that works. We can then set up our route table and be able to see the same things we would typically do with what command on Cisco? Pop quiz. What's the command to see all the routes in the Cisco?
Base route.
Nope. All the routes in your routing table on Cisco.
Oh, okay.
Show IP route. Let's see. You know your stuff. Show IP route on Cisco. What is it on Windows? That's right. I'm going to quiz y'all today.
Route print.
Route print. And what's it in Linux? Nobody uses Linux, huh? You all fell asleep in Jackie's class? Is that what happened? All right. Route, usually.
Route-N.
Yeah, it's actually route-in. Sometimes on the newer versions of Linux, it can actually be a whole different it's a whole different command than it used to be in the old days. So that's the reason I actually got silent there, because I about said the old one and I realized that isn't the right one anymore. I think it's IP route on some of those now. Route print is Windows. Route-in, I think you're right on the Linux side, unless there's something that replaced that with the whole IP thing. Okay. All good things to memorize, by the way. As IT guys, you're going to find it. Okie doke. That's it. So, as I promised you, lots and lots more information coming each week as we go through here, right? First couple were pretty easy breezy. Now there's some things you got to memorize. So in this case, the big thing from this chapter, module, whatever you want to call it, coming through is truly knowing how security zones work, knowing about the security or the zero trust architecture as it goes through here, where by default, we don't by default, we do not inspect traffic within the user zone. We do inspect traffic from the application zone to the user zone. And for us to go out is north-south. Anything between these sections is considered east-west. Knowing that we can use security zones as a form of network segmentation. There's lots of ways to do network segmentation. This is one way to do it. Know the different interface types and where you would use them. So the one that we didn't necessarily cover was tunnels. We will cover that in a later module as we go through. And your 3 main deployments as to how you would use a firewall. Layer 3 being the most common one that you go through, but this requires configuration changes if we were going to implement it. So if you were using another vendor and come in, You have to set up all the IP addressing routes, all that has to be funded out of this guy when we get it set up. Not DHCP necessarily on the inside, but you could use it for DHCP. Virtual wire allows us to do all the filtering and everything of a Palo Alto, but we don't have to change any configurations in the user's network. And then tap allows us just to get an idea of what's going on in their network. All right. Sub interfaces is basically your VLAN tags. Trying to think of anything. And then virtual routers, the idea there is that we can have multiple virtual routers inside. And a lot of times we would use those and associate those with multiple zones if we're doing multi-tenant type stuff, but you could also use it as just different virtual routing forwarding tables. In a Cisco, they would call these VRFs, and that is just virtual routing forwarding tables. So you can actually make a Cisco router act like multiple Cisco routers, where it has completely different routing tables inside of it. Okay. So let's get to the most fun you guys will have all day. Questions. All right. So which two items are supported routing protocols in a virtual router? OSPF, IGRP, EGP, or BGP?
And D.
A and D. Why do we not support B and C? What's the difference between A and D and B and C? Now, everybody in here should know this because you guys took those classes.
Is the B a Cisco proprietary protocol?
You got it. B and C are typically Cisco proprietary protocols. B specifically is. E is just more commonly not used as much anymore as BGP on its side. All right. So the generic ones that are out there used by all vendors kind of thing is your OSPF and your BGP side of the house. All right, which three interface types are valid on a Palo Alto firewall, Palo Alto Networks firewall? FC, layer 3, FCOE, TAP, and virtual wire.
BD and E.
Yep. What's FC?
Fiber channel.
Fiber channel. What's FCOE?
Fiber channel over Ethernet.
There you go. Does anybody have a clue what fiber channel really is?
Something they use in data centers.
That's right. Yep. So fiber channel, you typically would only see that at the data center level. It's kind of an old protocol. It was basically not Ethernet, right? It was a form of what we know as Ethernet today. Fiber channel was typically used at a high speed. It offered really high speeds, gig plus back in the days when Ethernet was nowhere near that kind of stuff. FCOE was doing that same protocol now just over Ethernet. That way we could use our existing infrastructure to do fiber channel type stuff. Which two firewall interface types can be added to a layer 3 type security zone? Tunnel, virtual wire, tap, or loopback? Two of those are valid.
Virtual wire is one.
Well, let's look through it. B. Yep. A, B, C, D, right? Well, the reason I'm hesitant on C is why?
Because it's layer 2.
Yeah.
Connects to switches.
You got it. So the key word here is a layer 3 type security zone. And
Yeah.
so a tap is typically meant for us just to listen on a layer 2 type section, right? Not to mention in that case, you have the tap zone, right? It had its own type specifically for that. So the other way of doing that, what was the other one that had its own specific type of zone too out of that list? Tap had its own type.
No.
Tunnel also had its own type too, right?
Yeah,
So that,
it's loop
by
back and
process of
virtual.
elimination, gets you down to the other two. Now let's go back and check B and D and make sure that they would be a layer 3 type. Can we assign an IP address to a loopback? Yeah, right. So that helps us know that that's a layer 3. Virtual wire, yes, allows us to listen on virtual or layer 3. We don't have to assign it an IP, but we could assign it an IP if we're going to do the NAT portion of it. And that's why it's available to those layer 3. So I know I took that the long way around, but when you get these questions on the cert or you're taking the final exam and how do I do process of elimination? First ones are, keyword here is layer 3, knock out the ones that aren't layer 3 type stuff. That'll help you on that side. Almost all these Palo Alto questions, that's the best way to go about it. Look for the keyword up here, start knocking those down on that side. Okay, which type of firewall interface enables passive monitoring of network traffic? That's your tap, right? And what keyword in that other one told you that? Passive monitoring, right? As opposed to, if it's not passive, it's active, which means we would have to be participating in that IP route, and therefore it would be layer 3 stuff on that side. All right. True or false, a layer 3 interface can be configured as dual stack with IPv4 and IPv6 addresses. True, right? In order to use IPv6, though, we have to do what? Yep, we actually have to turn it on at the firewall level in order for us to be able to use it. Cool. Let's make sure you're right. I'm sure you're all right. I don't scroll so hard. There you go. So AD, BDE, AD, BNA. That sound about right? Cool. All right. How are you guys doing on the weekly quizzes? Those still going all right? Cool. So we will do this lab on Thursday. It won't still take us the full time, but it will take more time because we got a lot more things to cover inside of it as opposed to the ones in the past. I think most people are still able to get to the labs, haven't had any issues with that. Okay. Let me know if you guys start having issues with the labs anywhere in there. All right. If nobody has any questions, we'll see you guys on Thursday. Thanks, guys.
I got a question.
Yeah.
So on the configuration of the interfaces, if you configure a layer 3 interface on a zone, could you configure other interfaces using that same zone?
Yes.
Same IP scheme, like so you could switch off of the zone?
You could switch between or have multiple interfaces assigned to one zone, but you probably wouldn't have the same IP address on both interfaces, right? Or are you asking if it's in 2 separate zones, would that work?
Well, no, I was just saying, so if you created a Ethernet layer 3 Ethernet interface, if you could do like some type of port mirroring or port shield or some type of thing where you could have other ports that worked along with the same IP address scheme, like on that zone. So like a switch, kind of use it like a switch without having another switch.
Yeah, so it would almost be like lag at that point, right? Where you're doing like LACP, where something where you would have redundancy. Is that what you're looking for?
Well, I just wondered, like, say you didn't have another, like you were wanting to come off of the firewall with another device on the same LAN. So like you'd set up your 192.168.1.1 subnet.
Uh-huh.
And then you wanted to use another interface basically as a layer 2 switch on that same network.
Yeah.
Is there a way you can set that up for another interface to kind of mirror that layer 3 zone you already set up?
Yeah, you would set your second port up as a layer 2 interface at that point and assign it to that security zone. Yep.
Okay.
Yep. Yeah, that's what the layer 2 interfaces is for, is so that you could essentially use some of those ports as a switch so that you don't have to have a physical switch if you didn't need that many ports. Or maybe like if you had this in a rack where you didn't have a switch there, you're switching up to like a network closet. You could do this to plug in like a monitoring box on the admin network or something like that. It could direct uplink there.
Okay. Yeah, that's what it did. Kind of was the layer 2 switching part of it was a little bit confusing to me on how it's implemented in the Palo Alto. That's what I seen it's there, but I didn't know quite how it worked.
Yeah, the goal is so that you could turn those Ethernet interfaces into essentially switch ports. And then when you do that, you assign those to a specific security zone inside the firewall. Yep. Yep. Cool. Anybody else got any questions? A Python question. All right. Fun.
So when I on the main project one, so
Okay.
I went to go get a grade check from Jackie,
Mhm.
and he went to go run it. So whenever I was doing it and I submitted it, it was working and it was popping up the graphs.
Mhm.
And then he tried to run it on last Tuesday or Thursday, and it popped up this. And then he tried to have me run it on mine. So I went back and watched your video, and I originally thought it. So how you were doing when you taught this, your like days, like your history, like how far back to pull
Right.
on the period, it wasn't working for you to just do 10-day or 10D.
Yeah, it changed somewhere.
But when I
Over
was
the
running
years.
it, it worked for me. But I didn't know if that was the original problem, why it stopped working. Because when I submitted it, it was working. So I went back into your video and I changed it to how you did it. But now when I run it, it pops up.
Too many requests, rate limited.
And he said he tried to run it on his own IP where he had no requests and it still did the same thing. So I didn't know if that was on my end with the code or if that's on the Y-Finances.
That sounds like the Y-Finance package now has a way for you have to do rate limiting on it. I would go look up the package and see if there's now a variable that you need to set or like it has, or you put a time delay in so that when you have a go search for each one of those, just put time.sleep
I
2 seconds or something.
I tried that. I tried time.sleep like for like 5 seconds.
Uh-huh.
For each one, and it still did it. It would just sit there and go loading, and it would just keep going down. And it would never stop. It just would never pull it up. So I was like, when he was trying to grade it, or like, because he was trying to look at it to give me a grade check,
Right.
track, but
Yeah, that to me looks like the Y-Finance package. That doesn't look like a campus issue or anything. It looks like the way they do Y-Finance has changed, and I would have to go look at the new packages.
because like whenever I was doing it and like I would run it, it would pop up the graphs, and then I submitted it. But then when he tried to look at it, I don't know if it changed within those few days.
It shouldn't have changed because you did a pip freeze before you submitted, right? So it should have pulled that specific version of Y-Finance. The only thing I can think of is if you trashed Y-Finance, go like in my video and go back and pull an old one, like the one that I used in my video, because you'll see it in my pip requirements when I flash it to you guys. Grab that version specifically and put it into your pip requirements, and then do a pip install requirements.
So if I just redid this all over again, do you think it would fix it? Or
It's possible, or they came out with a patch for that one, and now you just need to reinstall Y-Finance, see if it goes to a new version. So now if you look in your pip requirements file, you'll see what version of Y-Finance is in there. Okay, so like basically write that down, remove that line out of there, and then do a pip uninstall Y-Finance, then do a pip install Y-Finance, see if it, and then do your pip freeze, see if that version changed. They may have had a change in their version there. You could also go out to the Y-Finance on pip and find out if there's a newer version out there that fixed that.
yeah, I'm gonna go talk to him. I guess I could just email him about it, but if it fixes it,
More than likely email with Jackie. I don't know that he's here today. Oh, actually, he is here today.
it's like his office hours like 1 to 4 on Tuesday and Thursday.
Okay, yep.
Yeah, I went in there before. Talked to him about it.
Yes, and my things have not released. I'm fixing that. I just several people messaged me and I didn't realize that was that broken. So I'm fixing that today. Yep. I'm here till like 7. I got your letter sent, and I'm sending it to Kevin tonight. Him and I are meeting tonight. So once I get that all in, then off to you and we'll be good to go. Yep, no problem. Oops.
Hey, Jason,
Yeah.
can you hear me okay?
Sorry, I unplugged my mic. What's up?
Somebody brought up Python, so I just remember I just sent an email to Melissa and Kevin
I saw that.
regarding
Thank you.
your they did reply to me and saying that they'll reevaluate and see if they can get you more Python courses or something.
That's funny.
I just want you to go back to teaching Python. That's all I want, man. I mean, I
I,
heard so much
appreciate that.
good stuff. That's all.
I
I mean,
appreciate that.
I really want to take the advanced, but I don't want to get to the advanced without going to the beginning Python course that you teach. You know
Yeah,
what
and
I'm saying?
you'll have to, because even if you take it from another college, students that have done that and then try to jump into advanced, it just doesn't work right.
Yeah.
Because of the way the projects are structured, I keep that going through the advanced side.
Yeah.
So you're kind of at a disadvantage if you don't.
It helps if it's the same instructor, because you would follow your beginning course and then take it to the advanced, rather than if I take it to some other instructor where they may have a different material, covering different material, different way of doing it, right? And then
Actually, the ones that are teaching the Python courses right now are all using my materials. So it would be the same as if I'm teaching it. They're not using their own materials, if that makes sense.
okay. But any changes yet? No, probably no.
What's that now?
Due to summer, are you going to be teaching Python 1 in summer?
I haven't heard anything yet. We're about to go through a staff meeting on Friday, and I'll bring that up, that students are still asking. So,
Yep, that'd be great.
all right. I appreciate that again.
All right, no worries. Take care, man.
All right. Have a good one. We'll see you, RJ.
Take care. Bye.
Yep. See you, bud.